19 Mechanical properties every mechanical engineer should know. Different types of materials. Most materials can be categorized into two types of materials, metals and nonmetals. What are the two main types of metals? Ferrous and non-ferrous metals. The difference between ferrous and non-ferrous metals is simple. Ferrous metals typically contain iron and other small materials and is often used in the mechanical industry, while non-ferrous contains no iron and is made up of other materials like copper, zinc, aluminum and magnesium. When assessing the mechanical properties of any material, it's usually metals that we're analyzing. Here are some of the most common mechanical properties that define different types of metal. Number 1. Strength. The measurement of how much load a material can withstand before failure. The more load a material can bear, the more strength it has. There are three different types of strength based on loading types, which are A. Compressive strength, B. Shear strength, C. Tensile strength. In regards to deformation before fracture, the three types of strength are A. Elastic strength, B. Ultimate strength, C. Yield strength. Number 2. Fatigue strength. The amount of cycles a material can withstand under fluctuating stress, cyclic loading, upon reaching failure. Fatigue refers to the failure of a material under cyclic loading prior to reaching its ultimate limit. Number 3. Brittleness. Brittleness is when a material breaks suddenly under stress, without exhibiting much elastic deformation or changes in dimension. Number 4. Stiffness. A material's ability to resist significant elastic deformation while loading. The less deformation a material exhibits during loading, the stiffer it is. Number 5. Hardness. Hardness is defined by a material's ability to resist various forms of deformation, indentation and penetration. Also refers to its resistance to scratching, scraping, drilling, chipping and wear and tear. Number 6. Toughness. Toughness is defined by the material's capacity to withstand elastic and plastic deformation without failure. Typically measured by the amount of energy a material can absorb before fracturing. Number 7. Embrittlement. The result of metal losing its ductility and becoming brittle due to chemical or physical changes. Number 8. Homogeneity. Any material that has the same properties throughout its entire geometry. A homogeneous material cannot be mechanically separated or identified individually. Certain types of homogeneous material includes plastics, metals, glass, paper, resins and coatings. Number 9. Isotropy. Often confused with homogeneity, isotropic materials exhibit the same properties in any direction or orientation, whereas homogeneous materials have the same properties regardless of direction. Number 10. Anisotropy. A material that exhibits different properties based on its direction or orientation. For example, in computer graphics, an anisotropic surface changes in appearance depending on the angle it's being displayed at. Number 11. Elasticity. Materials that rebound back to their original dimensions after deformation, or being removed from its load. Every material has a certain elastic limit before becoming deformed permanently, otherwise known as plasticity deformation. Number 12. Plasticity. A type of permanent deformation that occurs under stress before resulting in failure. Commonly used in metal shaping to achieve certain shapes and forms. Number 13. Ductility. Ductility is the result of solid material becoming stretched due to tensile stress. A common application of this process is turning metal into wiring. Number 14. Malleability. The ability to plastically deform a material or significantly change its shape without becoming fractured. Number 15. Machinability. The ease of which a metal part can be cut without sacrificing the quality of the finish. Number 16. Creep. A slow and gradual deformation, or change in dimensions, of materials under a certain applied load. Measured by the influence of time and temperature. Typically occurs at high temperatures, but can also occur at room temperature, albeit much more slowly. Number 17. Resilience. The ability to absorb energy while being elastically deformed, and releasing that energy after being unloaded. Proof resilience is the maximum amount of energy a material can absorb before permanent deformation. Number 18. Damping. Damping refers to dissipating the amount of energy used to create vibration, oscillation or stress. A material with a good damping property, such as cast iron, is capable of absorbing high amounts of vibration. Number 19. Thermal expansion. A change in shape, volume or area caused by changes in temperature. The coefficient of thermal expansion refers to the amount a material's shape or size will change during exposure to a change in temperature. Please, support, and subscribe. Comment which video you want.